So if we have CO2, CO2, okay, so CO2, is that an element, a compound, or a molecule? Or it could be multiple ones as well. Can you guys see my whiteboard? Okay, I have, let's see, resume. Okay, so somebody said a molecule, somebody says an element. Okay, so what is the definition? Let's go back over those definitions. A molecule. Anybody want to give me the definition of a molecule? Anyone? A molecule is composed of two or more elements. Okay, a compound what's the definition of a compound? Thank you, Maria, for that molecule. Compound. Paulina, a compound. Samantha. A compound is a pure substance that can't be broken down. Are you sure about that? I thought that's an element. Compound. So let me give you an example of a compound. So an example of a compound is something like sugar, right? We know sugar is made of C. It's C11. Oh, sorry, C12, H22, O11, right? Something composed of two or more different elements or separate elements. Good job, Samantha. Okay, so a compound is composed of two or more different elements. And then an element is a pure substance that can't be broken down yeah, that doesn't. So it's a pure substance that can't be broken down and only contains a single type of atom. Okay? Okay, so now we have a definition, a general definition, right? So CO2, is that an element, a compound, or a molecule? And again, it could be multiple ones. We're going to use M for molecule. C for compound, and E for element. Okay, so we have a C. Okay, so we know that this guy is a compound. Okay, is it an element? That's right. No, it's not an element. Is it a molecule? Is it composed of two or more elements? Brittany?
No.
It isn't. I see a carbon. That's one.
Oh,
I see,
yeah.
okay, so yeah, it's also a molecule. Okay, so I should probably put this in different colors. I don't think it's. Anybody colorblind? So say this guy is C and M. Okay, so it's a compound and it's a molecule. Okay, so let's see. What about carbon, C? Is that a compound?
No.
No. No. Okay, is it a molecule?
No.
No. Is it a element?
Yes.
Okay, so we know it's just C. Okay. What about O2, oxygen gas, O2? Is that a compound? Definition, composed of two or more different elements. Is it a compound? No, that's right, Bernice. Is it a molecule?
Yes.
It is a molecule. Is it an element? Pure substance that can be broken down and only contains a single type of atom. Does it only contain a single type? Yes, somebody said it's an element. Good job, Bertha. Okay, what about S8? S8. Is that a compound? Are you sure? Definition of a compound. So we say, somebody said it's an element. That's true, it's an element because it only contains a single type of atom. Look at that, single type of atom. It only has S's in it. Compound, composed of two or more different elements. I see only S there. Is that different? Oh, so it's not a compound. That's right, Bernice. Okay, is it a molecule? Yes, that's right, it's a molecule. Good job, Maria. Okay, simple. Okay, it's important that you guys understand these definitions because this is the beginning of chemistry, right? This is the easy part. So we know that a molecule is composed of two or more elements. It could be the same elements or it could be different elements. We know a compound is composed of two or more different elements. And we know an element is going to be a pure substance that can only be broken down and only contains one type. Okay, it could be one or it could be 50. right? And that would still be considered an element, okay? So we talked about on Friday, the last time we met, not on Friday, whatever day it was, Tuesday, we talked about the diatomic elements. Diatomic elements, di meaning two, atomic meaning two atoms, diatomic elements. Anybody remember the diatomic elements? I gave you guys an anagram. It have no fear of ice cold beer. Okay, that's 7. So there's 7 of them. 1, 2, 3, 4, 5, 6, 7. So can you tell me the 7? Oh, somebody said we have oxygen. That's right, oxygen. We have nitrogen. We have iodine. We have bromine. We have fluorine. We have hydrogen. Yeah. So what is that C? No, not Enstadine. Have no fear of ice cold beer. Do you see an A in that one? Chlorine, that's right. Okay, so those are 5. Have no fear of ice cold beer. So do you guys see that? Pauline, do you see it? Is it Nada? Do you see it?
Yeah.
Okay. Okay, you see how we came up with that? So those are our 7 diatomic. Now, what does that mean? Diatomic means, I said, 2. So that means that when they're naturally occurring, when they're by themselves, when they're alone, right? When they're the element that's reacting, we write them as H2. Now, this 2 here is called a subscript. Let me write that down. Okay, subscript. It tells me how many hydrogens I have. Okay, so in this case, I have 2 hydrogens. So nitrogen, when it's all by itself, it's going to be written as N2. Fluorine, it's going to be written as F2. Oxygen is going to be written as O2. Iodine is going to be written as I2. Chlorine is going to be written as Cl2. And bromine is going to be written as Br2. Okay, so that's what diatomic means. Di meaning 2 atoms. So we have 2 atoms of hydrogen, we have 2 atoms of nitrogen, we have 2 atoms of fluorine, we have 2 atoms of oxygen, we have 2 atoms of iodine, we have 2 atoms of chlorine, and we have 2 atoms of bromine. Okay, you guys with me?
Yes.
Okay, so there are also atoms that are polyatomic. What does poly mean?
Does it mean like multiple?
That's right, multiple, right? It means multiple. So I wrote one up, S8. So sulfur is a polyatomic element. So, but sulfur is kind of weird. So most of the time it's S8, but sometimes it'll just be S by itself. Okay, but the majority of the time it's S8. And the other one is phosphorus, P4. Okay, so you definitely need to know your diatomics. I want you to know your polyatomics. Okay, are you guys with me?
Yes.
Okay, good. Okay, so let me start sharing the lecture notes. See where I left off. Okay. So we've talked about the definition of an element. We talked about the definition of a compound. Now, a compound also can't be broken down, or I should say, a compound is also a pure substance that cannot be broken down except by chemical change, right? That's the only way that we can break it down. We can't separate it by using its physical characteristics, okay? So here, a mixture is impure. It can be separated by physical means. So we can use physical characteristics to sit there and separate, right? So we can end up with a compound, which is pure, or we can end up with an element, which is also pure, okay? Well, a compound, which is also pure, can only be separated by chemical means. So only chemical reactions will allow us to separate that compound. So like, for instance, we talked about the chemical equation, right? So we had, let's say, water, H2O. So if we attach water to electricity, a lot of electricity, we can separate it to H, hydrogen gas, and oxygen gas. Okay, so in this case, we have a compound that we're breaking up the bonds to separate it into two individual elements. Okay, and I'm going to ask you a question. You guys should remember this from last week as well. Is this compound, is this chemical equation balanced? What do I mean by balanced? No, it's not balanced. Does anybody know what I mean by balanced? What does the law of conservation say?
What goes in has to come out. Like
What
same
goes in
amount?
has to come out. That's right. Good job, Bertha. Okay, so how many hydrogens do we have? So let's go ahead and write this down. We have H, we have O. We remember that this side is the reactant side. So how many hydrogens do I have on the reactant side?
2.
2. How many oxygens do I have on the reactant side?
1.
1.
Okay. And then on the product side, how many hydrogens do I have?
2.
And how many oxygens?
2.
Okay. So as Bernice was telling us, this is not balanced. So we have two hydrogens going in, 2 hydrogens coming out. We only have 1 oxygen going in and 1 oxygen going out. So then we're going to have to use our coefficients, which is the number that will be in front of the compound, and it pertains to the whole compound, right? To sit there and balance it out. So how can I balance it out? What coefficient can I put in front of water, in front of the hydrogen gas, in front of the oxygen gas to make everything balanced? So what do I need to put on my reactant side? What number? To make it so that my oxygen has 2 oxygens coming in, so to match up those 2 oxygens that are coming out. 2, that is correct. Thank you, Samantha and Adriana. So I put a 2 here. So that means now I have 2 oxygens coming in and I have 2 oxygens going out. But now I have 2 times 2 is 4. So I have 4 hydrogens. So how would I balance that out? What do I need to put in front of the hydrogen to make it 4? That's right. That's right. That's right. Everybody's chiming in on that one. I need to put it 2. So then that makes this 4. So now we're totally balanced. And we know that if there's not a number in front of it, it's always understood to be a 1. Okay. So if there's no number here, it's understood to mean just 1. That's my 1. Okay. Okay. Simple. So that's balancing chemicals. Yeah, can't even talk. That is balancing chemical equations. Okay. And I think we talked about that a little bit, but I want to talk about it a little bit more before we move on. Okay. Okay, so I'm going to add a screen. Okay, so let's assume that we have methane reacting with oxygen. So anytime that you have a combustion reaction that involves a hydrocarbon, this guy has only hydrogen and carbon, so it's called a hydrocarbon, you need oxygen for that to occur. If you take away the oxygen, you don't get any burning. Okay, so a combustion reaction, you're going to always end up with carbon dioxide and water. Okay, so if I want to balance this chemical equation, I'm going to write down those elements. Okay, CHO. So can you tell me how many carbons do I have on my reactant side? That's right, 1. How many hydrogens do I have on my reactant side? 4. That's correct. How many oxygens do I have on my reactant side? 2. That is correct. Okay, now what about my product side? How many carbons do I have on my product side? That's right, 1. Okay, how many hydrogens? That's right, 2. And how many oxygens? The correct answer is 3. So we have 2 that are coming from the CO2, and we have 1 that's coming from the water. Okay, so a total of 3. Is this a balanced chemical equation? That's right. No, it isn't. It's not balanced. So what do we need to do to balance it? Put a 2 in front of the H on the reactant side or on the product side? Product side. So I'm putting a 2 in front of the H2O. Okay, so now that means I have 4 hydrogens. Is that correct? How many oxygens do I have now? I have 4 because I have 2 from the CO2, and then I have 2 times 1, which is 2. So that gives me a total of 4. Okay. So is it balanced now? Put a 2 in front of the oxygen. On the reactant side? Okay, so I put a 2 here. So now that gives me 4. Piece of cake? Everybody gets it? Nobody not get it? Okay. So let's make it a little more challenging. This is too easy, so add another layer of complexity to it. Okay, so let's say we use another combustion reaction. We'll do let's do C4 H10 plus O2 yields CO2 plus H2O. Okay. Okay, Maria, what is the first thing that I want to do? I want to separate the elements. Okay. So I have a C, I have an H, and I have an O. Okay, so I write down the elements that are in the chemical equation. Okay, so how many carbons do I have on the reactant side? I have 4. Okay. How many hydrogens do I have on the reactant side? I have 10. Okay. And how many oxygens do I have on the reactant side? I have 2. Now on the product side, how many carbons do I have? One, that is correct. How many hydrogens? 2. And how many oxygens? 3. That's right. 3. So, okay. So is it balanced? No, it is not balanced. Okay, Alberto, what do I need to do to balance it? Where should I start?
Add a 4 in front of the, or behind the C.
Okay, in front of the C. We want to put it in front of it. So now, again, this is our coefficient. We need to put a 4 in front of that C. And I'm assuming you're talking about the carbon dioxide. So I want to put 4 in front of carbon dioxide. Okay, so that means now we have 4 carbons. How many oxygens do we have now?
You got 10, huh?
So I have 4 times 2.
Times 2.
That's 8.
8
plus,
and then,
I have 1 here.
9.
9. Okay, so I have 9. Okay, so is that balanced?
No.
No. Okay, Gabriella, so I have that hydrogen. Is that hydrogen balanced?
No.
No. So what do I need to do to balance that? So I have,
Do we put a 5 in front of H?
in front of the water?
Yeah.
So H2O, so we're going to put a 5 here. Okay, that's my 5. Oh, it looks like an S, doesn't it? Let's see. Keeps fixing it. So that's a 5. My first grader handwriting there. Okay, so that gives me 10 hydrogens. How many oxygens do I have now? 4 times 2 is what?
8.
8. And then how many oxygens do I have for the water? 5 times 1.
5.
Okay, so that's a total of 13. That's right, 13 total. Okay, so now I have 13 oxygens. Okay, now here's the thing, right? Our carbons are balanced, our hydrogens are balanced, but our oxygens are not balanced. But there's only one source of oxygen. One place where we're getting oxygen from, and that's from oxygen gas. So that kind of plays in our favor. What can I multiply O2 by to make it so it's 13? Do you guys remember fractions? Anybody remember fractions? No? Well, let me help you with some fractions here. So if I have, let's say, 2 over 2, what does that equal? Okay, so somebody was giving me a hard time there. 1. Okay, okay. So it equals 1. 2 over 2 is equals 1, right? So if I multiply this guy by, somebody said 6.5, or we could say 13 halves, which makes it easier to see, right? So then you're multiplying 2 by 13 halves, and that should equal 13. Is that right? 2 times 13 halves. So that's the same thing as saying 2 over 1. We do multiplication. The 2's are going to cancel out, and then we're left with just 13, right? You guys remember that? Good. Okay. So that would give me my 13, right? So my chemical equation would technically be balanced, right? So, because I have 4 coming in, 4 going out, 10 coming in, 10 coming out, 13 coming in, 13 coming out. So would that be balanced? Yes. Okay. Okay. So can I ask you a question? Let's see. Adriana, I have 2 of you guys. So either one of you guys can answer this. Okay. So Adriana, if I cut you in half, would you be okay? Cut you right down the middle. Would you be okay? No, you wouldn't, right? Okay. So if I cut a molecule in half or a compound in half, it's not going to be okay, right? So we need to figure a way of getting rid of that half, because that's what we're saying we're doing here, right? So the way that we would do that is multiply this whole equation by 2, because it's a half here, right? So 2 times this whole thing. So 2 times 1 is 2. So we have 2 C4 H10 plus 2 times 13 halves, which would just be 13, O2, yields 8 CO2 plus 10 H2O. Okay, you guys got that? Anybody not get that? No. Adriana? So does that make sense? Okay, excellent. So now you guys have gave me the permission to give you guys some problems to make you think, right? So let me see if I can give you a couple of problems to sit there and make you guys think. Okay. So we're gonna do this one. H6 plus O3 is ozone. I'm pretty sure that we talked about this one, but I like to always make sure you guys understand it because you're going to see it again and again and again. Then I'm going to add one more. Okay, so this equation B, that one is the equation for cellular respiration. That's what we do. This is C. This is what yeast does when there's no oxygen around, and it makes to make beer or to make wine. Okay. Okay. So what I'd like you guys to do, I'm going to put you guys in groups, and I'd like you guys to talk with each other, or text with each other, or some way of communicating with each other, and solve each of these three equations. Okay, I'm going to put you guys in three groups. Okay, group one is going to be responsible for A, definitely, but you want to solve all the equations because you want to check up on group two, right? Group two is going to be responsible for B, and group three is going to be responsible for C. So you guys are going to put the answers up on the boards. We're going to either agree with you or disagree with you. Can you guys see my screen? No, probably not.
Yeah.
Okay, you see the equations on it? Or is it a whiteboard?
No, we can see every. We can
Okay.
see everything.
Okay, good, good. Okay, so let's start off, like I said, with the very first one. Okay, group one, you guys want to help me guide me through this process? What am I going to do?
So first, we're going to have to separate them, break them down.
Okay, so we have a C, we have an H, and we have an O. Okay, so then what did you guys do?
And then we put how many we have on each side.
Okay.
So it would be 2 and 1.
2 and 1. For carbon? Isn't that a 5? Oh, no, this is the, oh, wrong equation. Sorry, my bad. Wrong equation. I'm like, that was for another class. Let me grab it. I'm glad that you caught that, and I didn't. Hold on, let me find it. This is what happens when you have 50 million different things open at once. Okay. Let's see, today, I think it's this one. No, that's okay. Give me 1 second while I get myself together. I'm a little bit of a hot mess right now. Share. Yeah, that is something wrong. There we go. This one. There we go. Sorry, my bad. So 2 and 1. Okay. Sorry. And then hydrogens.
6 and 2.
6 and 2. And oxygens.
3 and 3.
3 and 3. Okay. 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 So what am I going to do next?
So now we just have to get them to equal.
Okay. So what did you guys do to do that?
So in the C, we put a 1 in front of the C.
Okay, so it's understood to be 1. So
Oh, no, on the other one.
over here, you just put 1.
I think we did. Yes.
Are you okay? So then that's 1 times 1. How many is that? Is that 2 carbons?
We put 2.
We put a 2. Okay. So I should put a 2 here.
Mm-hmm.
Okay, so 2 times 1 is 2. Okay. And then on the H, you did what? Oh, wait, and see, how many oxygens do I have now? So that's 2 times 2 plus 1. So that's 4 plus 1. 4 plus 1 is what?
5.
Okay, so I have 5 oxygens now. Okay. Is it balanced?
No.
Okay, so what do I need to do next?
So right here is where we kind of stopped because we were all kind of confused on balancing the oxygens.
Okay, so let's start with the hydrogen since we know there's one source of hydrogen here, right? So it'll make it easier. So let's just get the hydrogen balance. How would I balance that hydrogen?
We put a 3
3
in front of the H2O.
Okay, so I put a 3 in front of it. Okay.
And 3 times 2 equals 6.
Okay, 6. Okay, so now how many oxygens do I have now? Okay, so we have 2 times 2 is what?
4.
4, okay. And then we have 3 times 1.
3.
Okay, so then that equals 7, right? So I have 7 oxygens. Ah, damn, that does not work out, does it? So, but I have 3 over here. So what can I do to make this 3 a 7? What can I multiply 3 by so that it equals 7? So 3 times x equals 7. Think about the fraction. What must x be? So we know it can't be a whole number because if it's 3 times 2, that would be 6. If it's 3 times 3, that would be 9. So it has to be somewhere between 3 between 3 and 2. So what would be a fraction that would be between 3 and 2? Anybody want to help out? So what can I multiply by 3 that would equal 7? So how can I cancel out that 3 and have 7 on top? Oh, there we go. Somebody had 7/3. So if we put 7/3 here, that would give me 7, right? Because 3 times 7/3 equals 7. Is that true? Yes. Okay. So now we got it balanced, right? But we know that we can't have a third of an atom, right? So what we need to do is we multiply everything by what now? The whole equation by what?
Is it 2?
So if I multiply it by 2, would I get rid of that 3 at the bottom?
No, by 3.
By
To
3,
cancel them
that's
out?
right. That's right. So if I multiply everything by 3, I cancel out that 3 at that bottom, right? And that's what we want to do. So then my final answer is going to be, let me erase this down here. Give me a little more room. My final answer is going to be 3 C2 H6 plus 7, because we know 3 times 7/3 is just going to be 7. O3 yields 6 CO2 plus 9 H2O. Matter. I'm just going to erase this part here. Okay, everybody sees that? That's times. Any questions? Okay, what about this next one? First thing I'm going to do, group 2, what am I going to do? Separate the elements. Okay, so now I have, we have C, H, and an O. Okay, so they're separated. What's next? Okay, so I have 6 carbon, 12 hydrogens, and 6 oxygens on my reactant side. Okay. Oops, sorry, not 6. We have 8. Because we have 6 here and 2 here. Is that right? Okay. And on my product side, I have 1, 2, and 3. Is it balanced?
No.
No. Okay, what do I need to do to balance it? Where should I start?
We started by putting a 6 in front of the CO2 on the right side.
Okay, so you're saying put a 6 here. Okay, so then that gives me 6 carbon. How many oxygens?
13.
13. Okay. And then,
A 6 in front of the H2O.
okay. Then that gives me how many oxygens?
18.
8. Okay. So my carbons are good, my hydrogens are good, but my oxygens, what do I need to do to balance those guys out?
Put hold up, I did it wrong. Put a 6 in front of the O2.
Put a 6 in front of the O2. Okay. So then that gives me, see, 6 times 2 is 12 plus 6. I believe that's 18. Okay, good.
Mm-hmm.
Okay. Now what about this last one? Group 3, you guys want to lead me through it? Okay, separate. Okay, so let's go ahead, separate. We have C, H, and an O. Okay. So how many carbons? On the reactant side, 6, 12, 6. Okay, 6, 12, and 6. Okay. On the product side, three, 6, 3. Okay. So where should I start at? Any suggestions? Multiply by 2 and carbon. Which one? We have carbon here, we have a carbon there. Both of them or just one of them? Somebody says 3. So which carbon? Are we talking about carbon dioxide or this is ethanol? So which one should I multiply by 2? Both of them or just one of them? Put a 3 in front of carbon. Okay, so if I put a 3 here, so that gives me how many carbons? 3 times 1 plus 2. So that would be 5 carbons. Does 5 equal 6? No. Okay, so what can I do to fix that? Do I want to put a 3 there? Put a 4? Okay, so let's go put a 4 there. Okay, so if I put a 4 there, then that gives me 6, right? Okay, so my carbons are good. What about my hydrogens? Bernice says we should put a 2 in front of the carbon dioxide. Okay, so if I put a 2 in front of the carbon dioxide, that gives me 4. Right, that's not giving me my 6. Can I give you guys a suggestion since we're like all over the place? Or do you guys just want to just keep going?
No, give us a suggestion.
Okay, so let me give you guys a suggestion. What I always do, I look for the element that is only in one spot on both sides. So this guy has hydrogen here, and this compound only has hydrogen, right? Where the other ones, they both have carbon dioxide and carbon dioxide. So what I would always do is get the one that has 1 on both sides balanced first. Okay, so I would start off with the hydrogen rather than starting off with the carbon, because there's 2 places I can get carbon. Okay, so if I started off with the hydrogen, what do I need to put in front of the ethanol, the second compound in our products? I need to put a 2. Okay, so if I put a 2 there, let's erase this one. Okay, so if I go ahead and put a 2 there, that gives me my 12 that I need, right? How many carbons do I have now? 2 times 2 is 4 plus 1. That's right, we have 5 carbons, right? And then how many oxygens do we have now? We have 2 plus 2 is 4. Okay, so if I put, now I need to come up with 6. So I have 4 here. So what do I need to put in front of here? So this would add up to a total of 6 carbons in front of this CO2. So right now I have 4. What do I need to put in front of the CO2 so it adds up to 6? A 2. Okay, so if I put a 2, that gives me 6 here. That gives me, let's see, 2 times 4 plus 2 times 1. So that's 6. Is that balanced? Okay, so when I have a very complicated problem, I want to find the easiest way to get there. The easiest way is always finding the element that is only showing up at one compound, showing up at only one of the compounds, and start with that one first. Okay, because then that makes it a little bit easier for us to solve it. Otherwise, we would have been going back and forth with the 4 and the, you know. Does that make sense? Thumbs up, thumbs down. You're like, no, you're a crazy man, you know. Good. Okay. Okay, so let's move forward. Share my screen. And close this guy down. Everybody got this though, before I erase. Okay. And let me clear. Okay, so let's go ahead and moving forward. I can find my lecture notes. Okay, so These are some of the common elements that we find in our society, like our CD, and which basically is made of silicon. We have gold, our gold bracelet. We have copper wire. We have iron bolts. We have copper pennies. We have lead weights. We have lead in pencils, which is carbon. And we have the silicon wafer again. So, and these are some compounds. So those are pure substances on the left-hand side, and then on the right-hand side, those guys are examples of compounds that we have, right? Water, lye, chalk, you know, okay? So, you guys are familiar with the periodic table. I've shown you the periodic table. Are you guys comfortable with the periodic table? Right? You guys understand that the periodic table has either one letter or two letters, and it's important for us to sit there and write the compounds the correct way. So the first thing is that that first letter has to be capital, right? So in the case of hydrogen, we know that this guy is hydrogen, right? So if I write so do all of these NOs mean exactly the same thing when I'm talking about chemicals? What does NO mean? Let me pull up my periodic table. Maybe this will help us. Can you guys see the periodic table? Okay, good, good. Okay, do you guys see my nose up top? Okay, what does n lowercase o mean to us? Does it mean anything as budding young chemist? Esmeralda, does it mean anything? NO?
I'm a little confused.
Okay. So let me kind of remind you guys. So here, this is hydrogen, right? The H, that big capital H, represents the symbol that we're talking about, right? So when we're writing our chemical compounds, instead of writing out hydrogen all the time, we can use just that symbol for the element. This guy, CO, is cobalt, capital C, lowercase o. Now, if I write it capital C, lowercase o, right, I know it's cobalt. But if I write it both capitals, what am I going to think that is, looking on our periodic table?
Carbon and oxygen.
I'm going to think it's carbon and oxygen, right? And then somebody's going to be adding carbon and oxygen rather than adding cobalt, right? They're going to add carbon monoxide instead of cobalt. Carbon monoxide is a poison, right? And then let's say I wanted to use that cobalt to make something really shiny. And so instead, I'm going to be adding a poisonous gas that's probably going to cause something else to happen. Is that what we want to convey? Yeah, no, maybe? No, we don't want to do that, right? Because we could cause bad things to happen by adding the wrong chemical. So it's important for us to understand what the symbol means and what we're writing. So if I write a lowercase n and a lowercase o, that doesn't tell me anything except no, you shouldn't be doing it. That's a dumb thing to do, right? No, you guys get that? Yes, acknowledgement. It lets me know that you guys are there. Yes, good, okay. So if I write a capital N and a lowercase o, what does that mean on our periodic table? Let me just full periodic table. What element am I talking about there? Esmeralda, can you find capital N, capital O on our periodic table? That's right. Nobelium. Nobelium, it has an atomic number of 102. That number up top is the atomic number. Let me click over here so you guys can see it big. Oops. Can you guys see it? So,
Yeah.
yep. So this here is called the atomic number. The atomic number lets me know that element, and it tells me the number of protons that element has. Okay, we'll be talking about protons here in a minute, in a couple of days, or in a couple of lectures. But this lets me know that that element has 102 protons. It also lets me know that element, what it is. And we know the symbol is capital N, capital O. Now, if I was saying NO, capital N, capital N, lowercase o. Now, if I had capital N and capital O, what is that telling me? Is that nobelium? No, it isn't, right? It is nitrogen and oxygen, right? So if it's capital N and capital O, we're talking about a compound that is nitrogen and oxygen, which we call nitrogen monoxide, right? So you want to be sure that you're writing the chemical in the correct format, right? Because otherwise, you're going to be making a huge mistake. Does that make sense? Yes, no, maybe. I need acknowledgement so we can move forward. Good job. Thank you, guys. I appreciate that. Okay. Questions, concerns, Cash? Okay, good. Let's move forward. Okay, so we're going to be using those elemental symbols to sit there and let us know which chemicals that we're working with. We've talked about the chemical formula, right? Or the chemical compound. So if I was talking about, let's say, sodium chloride. Sodium, if you guys look on your periodic table, again, sodium is what? What is the symbol for sodium? Samantha. Symbol for sodium. Can you guys find it on the periodic table? Na. Okay, and chlorine. Symbol for chlorine. You guys should know this because we know that chlorine is, okay? So if we were talking about sodium chloride, it would be NaCl, okay? And they're a compound together. So this guy represents our chemical formula. So this is the formula for sodium chloride. Together they form sodium chloride, okay? Is this guy a compound? Is it a molecule or is it an element? Sodium chloride. Nadia, compound, element, molecule. Just talked about it, right? Compound, that's right, compound. Compound, is it a molecule? What was that definition again? Somebody want to tell me? Come on, you guys aren't old as me. You can't be excused for forgetting already. Come on. How old are you guys? It is a molecule. That is correct. So the definition of a molecule is two or more elements, right? That is two or more elements, right? NaCl, two. Okay. And then a compound is two or more different elements. So that's two or more different elements. So it's also a compound. Okay. You know this is going to be on the test because I keep talking about it, right? Good. Acknowledgement, acknowledgement. Okay, so let's move forward. Okay. So we're talking about those formulas, chemical formulas, right? This is just basically giving you examples of those chemical formulas. So if we talked about hydrogen chloride, we know that there's one hydrogen and there's one chloride, or chlorine in this case, right? We talked about water. Water is H2O. How many hydrogens are in H2O? Two, that's right. How many oxygens? One, okay? So we know that there's a 2-to-1 ratio, right? If we have barium chloride has how many bariums? It's written right here. One barium, and how many chlorines? Two. Simple, right? Good. Okay, so we know that the atom is considered to be the smallest particle of an element, right? We talked about what a molecule is. Okay, so let's talk about the law of definite composition. The law of definite composition basically tells us that there's going to be a ratio, and that ratio is going to be fixed between two elements. Okay, so for instance, we talked about carbon monoxide. Cl. Right? So we have one carbon, one oxygen, right? So, but I also have carbon dioxide, CO2. Okay, that's one carbon to two oxygens. So carbon monoxide and carbon dioxide are not the same gas. Carbon monoxide kills us almost instantaneously, right? Where carbon dioxide, we actually breathe out, right? Over a long time, if the only thing that was present is carbon dioxide, then that would kill us, right? If there's no oxygen present. But this guy will kill us even if there is oxygen present, okay? So they're two different compounds. One has a 1-to-1 ratio, one has a 1-to-2 ratio. They're going to behave differently. They're not going to behave the same way, okay? So even if we have carbon monoxide, that doesn't mean that it's going to act like carbon dioxide. It does not. Okay, does that make sense? And so there is that fixed ratio between those two compounds. Okay, and that ratio can be constrained as mass, or it can also be constrained as quantity. Okay, and it means essentially the same thing. Okay, does that make sense? And so if I have 2 tons of carbon dioxide, it's still going to be carbon dioxide. So that sample ratio should be exactly the same. That mass ratio should be exactly the same. Okay? Are you guys with me? Acknowledgement? Yes.
Yes.
Okay, good. I should make you guys teach a class where you're talking to a black screen. It is so frustrating because you're like, everybody's on black, you don't see anybody's face. You can't see their expression. So you're like, if they know it, they know it. If they don't, they don't, right? So I need that acknowledgement since you guys are not going to share your cameras with me and I don't get to see your cute faces and see whether or not you're actually getting it. Can't this work? Okay, so let's keep going. Since I went on my little hiatus. Okay, so matter has characteristics of electrical charges. So you're going to have things that are going to be positive and negative, right? So if I have 2 positive things that come together, what happens? If I bring 2 positive things together, what's going to happen? Anybody want to take a guess? So have you guys ever played with magnets? So actually, no, they attract as if they're negative. So if I have two things that are positive, they're going to repel each other. So if like charges, positive and positive come together, as soon as they get together, they're going to shoot away from each other, right? So if you ever play with a magnet and you flip the magnet on the other side, one side will be a positive, one side will be a negative, one side will be a positive, one side will be a negative, and then you bring it together. So if you bring the opposites together, they attract, right? So do you guys remember, how many of you guys have dated? Anybody dated? Anybody got a boo? Okay, we have one person in this class that dated. Okay, now everybody's saying they dated. Good, good. Okay, so you dated at some point, right? So do you remember that very first time when you started dating, like say when you were in high school, and you come home to your mom or your dad or whatever, say, oh my gosh, Mom, I found the cutest boy. He is just so fine and so hot and everything like that. He asked me out. Oh my God, I'm getting, right? Remember that? Anybody remember that? Damn, this is a rough crowd. Yes, I have one yes. Okay, so one person remembered that. And your mom said, oh, baby, who is it? Who is it? Who is it? And you're like, Mom, it is Johnny Walker. You know, Johnny, oh, he's just so attractive. I love Johnny. Oh, Johnny, right? And your mom said, who? Johnny Walker from the Walker family down the road? No, you cannot date that boy. No, His dad was a criminal. He's a criminal. His brother's a criminal. They're all criminals. You cannot date him. What did you do? What did you do?
Date the boy.
You dated him, right? Admit it. Everybody admit it. You dated him even though your mom told you not to. You stuck around the corner, dated him. Why? I'll tell you why. Because opposites attract. Okay? Opposites are always going to attract. If you're the good kid, then you want to be with the bad kid, right? Because it attracts. And you're thinking, I can change him. I can make him a good man. I can balance him out, right? That's what it was. Opposites attract. Now, if it's the same charges, they're going to repel. Your mama wanted you to date Billy. Billy, went to church and he's got straight A's and all those things. And you're like, forget Billy. Oh my God, Billy, he's boring. I don't want him because he's kind of like you. He was positive. He was that positive charge. But Johnny was that negative charge. So you're positive, he's negative, it comes together. You have that attraction. Where two things that are positive, they're going to repel each other, right? He gets on my nerves, right? Billy got on your nerves because he's just like you, right? Do you guys get that? Do you see the analogy? Okay, so remember, opposites are always going to attract. Okay, it's chemistry. Okay. So if I put two positives together, they're going to repel each other. If I put two negatives together, they're going to repel each other. But if I'm a positive and a negative, we're going to attract. Okay. So that's going to be important. That is going to be one of the major things that we need to understand about chemistry is that we need that attraction. That's going to be an important part of chemistry. Okay. So this is just a little experiment that basically shows it. So if I take this silk cloth and I rub it on this glass rod, and then I touch one of the balls with it, it causes one of those balls to have the same charge. And positively charged, the other ball also is positively charged, and so then it's going to end up repelling. Okay. So then if I take a fur cloth and then I rub it on a plastic rod, a rubber rod, and I touch it with it, one becomes negative, the other becomes positive, so then they attract. Make sense? You see it? Well, you can see it on the diagram. You can also YouTube it. Somebody who's done it on YouTube. Okay, so we talked about the chemical reactions. We talked about the products and we talked about the reactants, right? So we know that this side here is our reactants. This side here is our products. We've balanced chemical equations. So you guys are already familiar with balancing chemical equations. Pretty confident. Okay, so let's talk about energy. So what is that law? The law that we basically base our chemical equation on. Law of what? Balancing those chemical equations.
Law of attraction?
Not a law of attraction. Now you're making up laws that we use for balancing chemical equations. What is it? I said it. What must go in, must come out. What goes in, comes out. What is that law?
Was it the law of conservation?
Law of conservation. That's right. It's the law of conservation. So the law of conservation basically states that what goes in must come out. Now, this also pertains to energy, right? So it pertains to matter, but it also pertains to energy. Okay, so the law of conservation of energy says exactly the same thing. So what goes in has to come out. Now, it can be transformed to other forms of energy, but at the end of the day, that energy that you put in has to come out in some form. Okay, so let's start talking a little bit about energy in terms of chemistry. Okay, energy is just basically the ability to do work or to transfer heat. That's what it boils down to. So either you're doing work, right? So you're like a turbine turning, or transfer heat. You're causing flames to burn, so you're making a lot of heat that way, right? So that is considered to be energy. So there are two major types of energy. Well, two major types that we talk about. We have kinetic energy, right? So that's the energy due to movement, and the other one is called potential energy. That's energy that's kind of like stored up, right? Or a result of being in a location, right? So for instance, potential energy, say we have a person that's standing on the top of a waterfall, or let's say a dam on the top of a waterfall, right? So we have that dam at the top of a waterfall that's stopping all the water from flowing there. Now, as soon as I let that dam down, that potential energy starts becoming kinetic energy. And we can use that water flowing down the waterfall to sit there and power things, right? To turn things, make things work, right? So then we're going from that potential energy to kinetic energy. Does that make sense?
Yeah.
Okay. So when we're talking about energy related to chemistry, we have energy that's often associated with heat. So it's the transfer of heat. So if we're putting heat into a reaction, right, that's going to be endothermic. If we're getting heat out of a reaction, then that's going to be exothermic, okay? So if I'm sitting next to a campfire, is that going to be the log burning and generating heat? Is that going to be an endothermic reaction or an exothermic reaction?
Exothermic?
It's going to be exothermic because energy is being released by that log burning. Now, you taking in that heat, is that going to be an endothermic reaction or is that going to be an exothermic reaction?
Endothermic.
That's right, endothermic. Okay, so exothermic reactions basically is where heat is being released to your surroundings, being released, okay? Where an endothermic reaction, and it's ENDO instead of INDO. Endothermic reaction, that's basically heat being absorbed or internalized. So you're putting heat into the reaction. So in this case, photosynthesis, we're putting that sunlight into the reaction to cause that reaction to make sugar and oxygen, right? So that's what plants. Okay. So again, this is the definition of potential energy. This is the book's definition. This is the definition of kinetic energy. Here's an example of exothermic reactions. Okay, so we can relate energy to mass. The way that we relate energy to mass is by using Einstein's theory, and it's E equals mc squared, where E equals energy, M equals mass, and C represents the speed of light. Or we could say velocity, right? So we could say energy equals mv squared, which is velocity. Okay, so now I want you guys to think about this. Okay, so let's say we're in a classroom, right? And, you know, Maria is, you know, relatively a good student and everything like that, right? And so Maria says something that was really off center, not normal for her normal self, right? And so I get a little annoyed and I throw an eraser at her. I just chuck it at her, right? just slowly chuck at her, not too fast, right? So that eraser and that speed, right? That's going to produce a form of energy, right? Now, let's say who's going to be my bad Paulina. Paulina is going to be my bad student. Not that Paulina is a bad student. I'm just using her as an example right now. I know Paulina is going to be an excellent student, right, Paulina? She doesn't acknowledge me, so she's already working on that bad part. Are you there, Paulina?
Yes.
I get that giggle now, right? So Paulina, total different subject. I get that eraser and I just work really, really hard. Which one is going to have more energy? Me tossing it towards Maria or me chucking it towards Paulina?
Chucking it.
Chucking it. Why?
There's more power going into it.
There's more velocity, right? So there's more velocity towards it, and as you say, more power, more force behind it, right? So that's going to have more energy associated. So energy is going to increase with velocity. So they're going to be what we call directly proportional, right? So they're both going to go up at the same time. Okay? Where me just tossing it, right? Those guys, it's going to be lower, right? So in that case, it's lower velocity. So then it's going to go down. Okay, so they're directly, so they either both go up, energy goes up as velocity goes up, or they go down because velocity is going down, energy is going down. Okay. So keep that in mind. We'll talk more about proportionality. Okay, but that also lets us know about energy. Energy is going to be dependent on mass and also velocity. So that was the case where we have velocity. Now let's say that I use my coffee cup to throw at Paulina, and then still the eraser. So my coffee cup weighs about 50 times more than the eraser does. So which is going to hurt a lot worse, the coffee cup or the eraser?
Coffee cup.
Why?
Because it's heavier.
Because it's heavier. And it's also going to have more energy behind it. If I'm throwing it at the same speed, it's going to have exactly the same. It's not going to have the same energy. It's going to have more energy because it weighs 50 times more, right? Okay. Does that make sense?
Yes.
Okay, good. Okay, so we've talked about the law of conservation. This is your book's definition. You want to know your book's definition, but you also want to understand it the way that we've kind of learned it, right? And that helps us remember it. So the book's definition of the law of conservation of mass and energy is just basically the energy that we're basically putting in has to equal the energy that we're getting out. Mass that we're putting in has to equal the mass that we're getting out, okay? So the key is that during this process, right, we're never creating or destroying energy. Instead, we're just conserving it. We're just changing its form, right? That's all we're doing, okay? So let me give you an example. So this is basically how how we get electricity, right? So if we take a look here, so here we have natural gas. So we burn natural gas. Natural gas burns. That causes this boiler to boil this water. This water makes steam. Steam then is pushed through this pipe. This steam then turns this turbine. So we went from chemical energy, right? We're breaking those bonds by burning natural gases to what we call, this guy would be work or work energy. So basically we're producing steam. That steam is going to be pushing through here. So we're making a pressure, right? And then that pressure turns that turbine. So that work is being done to make that turbine turn. So then that turbine turns, that causes us to turn this generator. This generator is turning, makes electric energy, right? So we make those electrons that are now free to move around, and those electrons go through the cords. Then we're able to sit there and power our lights. We're able to power our range. We're able to power our TV, right? So the thing is that the energy that we put in initially should equal the energy that we're getting out by powering all of our household appliances, okay? So that's conservation. Okay, you guys get that? Yes, no, maybe? Okay, okay, so that's chapter 2. Let's see, how are we doing? So we have an hour roughly. Okay, so what we're gonna do is, you guys know where to find, just a reminder, where to find all of your lecture notes and all of that stuff. Let's see. Find.
I was
Yeah.
actually gonna ask where we can find the recorded lectures.
Okay.
I'm
so
not sure
that's-
if you've posted them or like where we can
Yeah.
find them. I don't know.
Yes, they are being posted. Let me share that with you here. Let me pull that up. So if you go under modules, let's see. I'm going to go to student view because I have a lot more stuff shown on mine than shown on yours. If I go into modules, the first thing that pops up is recorded lectures and reading assignments. So there, the very first thing that we've talked about is the discussion. So we discussed the syllabus. So that was the very first thing that we've done. That would be our very first chapter 2 lecture. Today we have part 2. Part 2 will be coming up here soon. And then gradually what I'm going to do, I'm going to give you all my lectures that I've given in my class in Chem 22 over the last couple of semesters. So they're all going to be there. And then once we go over it with our own lecture, we go it face to face, I will actually start putting up your lectures to take its place. Okay. So you have the ability to get ahead if you choose to get ahead. Now, these are also, some of them have assignments associated with them. There'll be questions that you have to answer that's going to be associated with them. Okay. We're in the process of learning how to do that. Okay. So all your recorded lectures are going to be under this tab. So all you have to do is click onto this tab here, and it will take us to your recording lectures. So right now there should only be 2 there. There's going to be a 3rd one after we finish with editing this lecture. Okay.
Thank you.
So the next thing is, this is your Chem 22 getting started. So this is your textbook. This is only a temporary copy of your textbook that you guys can get. You should get your own copy. It's good to have a physical copy. For me, I can speak for myself. I like a physical copy. An e-copy kind of sense. Okay. This was the tab to Chem 101. You already have your Chem 101 assignments. You need to make sure that you get them done. If you've not got them done, then that's an issue. This was your intro assignment. You should have already done this one as well. You should have already introduced yourself. Okay. And this is just that very first assignment of getting you guys started for Chem 101. So after you've already registered for Chem 101, you should be able to do that. So at this point, you should have paid for Chem 101. It's 2 weeks out already. This will be our 3rd week right now. So that 2-week trial period should be over. So you want to activate your Chem 101. Otherwise, I don't see your homework grade. If I don't see your homework grade, I can't give you homework points. At this point, you should have picked up your kit, right? So the last day to pick it up was yesterday. Anybody not pick up their kit? If you've not picked up your kit, you need to get in contact with Tony Choi. Click on this assignment. It will give you the information. It will give you Tony's email. So you want to make sure that you connect with Tony, okay? Your very first lab was a lab demo. So you guys need to make sure you guys get this done by this Friday, because it's technically due by Friday. So you want to try to get those done. Now, the rule is you guys are going to be going pretty much at your own pace. I don't have everything up, but I'm trying to get everything located so that it is up. It's going to take me a minute because I have a lot of classes and I'm still kind of pushing everything through to make it run a little smoother than it has in the past. So bear with me, be patient, but soon you're going to have all of your labs. They're going to be recordings of me doing the lab or me having someone else do the lab for you. So you guys can see how the labs are being done, okay? We will also have those lab sessions on Friday so you guys can, because you guys either going to have to give me a link to that lab or you're going to have to say that you came to that session to let me know that you were there and you did it with me, okay? Now, doing it with me doesn't mean that you use a black screen. It means that you actually are showing your screen as you do the lab. So I'll be able to sit there and see that you're doing it and doing it well, and not your little brother's doing it for you, okay? Or cousin or husband, girlfriend, or you know what I mean, okay? So these are all resources that you guys are going to need for this class. If you actually go to the very end, There's one that says chemical packet. That is everything that you have here. And I will be fixing this. You guys have a couple of things that you don't need for this class. It's for my other class. And I uploaded the wrong sheet, not my Harnell sheet. So I have to correct it and put in the Harnell sheet instead of my West Hills one. So, and that's going to get done. It's just taking me a minute to get all of that taken care of. Okay. Let's see. This here, this is the very first unit that we're working with. So this is your chapter 2, your chapter 3. Now, if you look here, this is the lecture notes right here, the PowerPoint presentations. So this is where you would download the lecture notes that I'm going over. Okay. So we're going to be doing, we're going to start our lecture for the 3rd chapter here in a minute. Okay. And then here, this here is just extra material. So let's say that you don't understand anything that I say, and you're like, you know, he's the nicest guy. He's very attractive, but I can't understand anything he's saying. Here are some YouTube personalities that you can go to that are talking about the topics that we're talking about in that chapter. So you, if you don't like me, then you can go to them, right? You don't have to like me. You just have to acknowledge that I'm cute, that's all. So, and do your best to pass this class, right? So I'm providing you with other resources. So these are some other resources that you guys can use for that. So this here is going to be chapter 5. This is going to be the next chapter that we're going to be going over. Again, these guys are going to be slightly modified. I'm trying to make improvements so that the units work out to your favor, better for you. And so you have a complete understanding. So this chapter, although chapter 8 isn't on here, we've talked about chapter 8. That's the balancing chemical equations. Talked about it in chapter 2, but you really get into it in a lot of in-depth in chapter 8. But I wanted you guys to get an early start on it. So you guys will have your homework assignment that's going to be associated with this. You're going to have your homework assignment that's going to be associated with this. That is going to be popping up here soon too, which is nice. So I'll fix that as well. Okay. So do you guys, can you see where everything is at? Is it making sense?
Yeah.
Okay. Okay. And what I'll do is, because the way I have it set up, not all of your units are showing right now. We will get it so that all your units are going to be showing. So again, you will have the ability to do each one, but it's going to require you to get your homework assignment done. It's going to require you to get your exams done. So you guys are doing this at your own pace. Okay. So you don't have to do it when I want you to do it. You got to do it before the class ends, but don't wait till the last minute to do it. Because there's a tendency, particularly students that are doing it online, they wait till that last week to try to get everything done. Can't do that for chemistry. Otherwise, you're going to fail this class. Okay. So that's why I'm kind of trying to pace you guys right now to sit there and do it. And then gradually I'll let you loose to do everything at your own speed. Okay. Any questions?
Are we gonna have a lab session this Friday?
Yes, you're going to have a lab session this Friday. It's going to be, well, it's not going to be a real lab session. All it is going to be another simulation, because I'm giving you guys time to get your kits, because some of you guys had to have your kit sent to you, and it takes about 5 to 7 days for that to happen. I recognize that. So, and you also needed to get your supplies. So by next week, I said on Monday, you should have everything, but you're not going to need it till that Friday. Friday will be the first day that we do a physical lab. Not this Friday, but next Friday, which is the 24th. That's going to be our very first physical lab. Okay. Does that answer that question?
Yeah, thank you.
Okay. Any other questions? You guys have great questions. Keep asking.
Good question.
Yeah.
So where can we find the list of like this, or not? I don't know if it's like the school supplies that we needed for this class.
It was actually sent to you via email. Did you not receive it?
Oh, okay. I don't think. Should it be like in the inbox in Canvas?
It should be in your inbox in
Okay.
Canvas.
I'll just check that. Thank you.
Yeah. And what I'll do is I'll put it also under getting started. I'll put the list under getting started as well too. So I'll just say lab supplies you need to purchase. Okay. So
Okay.
I'll do that later today. I can't do it right now, but I'll do it a little bit later today. Okay.
Oh, I have another question.
Yep.
Oh, can you please send to the books that we need and the Chem 101 to the bookstore so I can buy over there? It's because I have some money in the bookstore.
I get, okay, so the book that you're gonna need, so your book should be in the bookstore because I used the same book last semester. So the book that you need is listed right here. Let me find it. Okay, so this is the book that you need. This is the ISBN number. If you look at the title, so if you just look for this title, say Introductory to Chemistry and Active Learning Approach. So any edition, you can use that. Your Chem 101 subscription, let me see. I think that you guys actually have you can buy a code to enter for your activation. Okay, so I think you guys already have that available at the bookstore.
Yeah, I know that, but when they try to find what books do we need, I don't know. You need to send them the book.
I've already done that. I've already sent them the book. And so what I'm saying is that it should be in the bookstore if you let them know this is the title of the book. I've actually sent them that. And then for your Chem 101, it is a code that they'll give you that you'll enter when you activate your Chem 101, because Chem 101 is an online subscription. It is not a book.
Okay, yeah, I know. Okay, thank you.
Okay, no problem. Okay, any other questions? Good question so far.
Yeah, for the code, do I ask for it at the library? Oh, no, wait, at the bookstore?
At the bookstore, yes. So what you would do is you'd say that I need to get a Chem 101 subscription. And your campus, I mean, I'm not the only instructor that uses, so there should be multiple instructors that are using it. Now, if you're still having trouble getting your subscription activated, then what you can do is contact Chem 101 and they'll give you guys a workaround. Because I know that there's somebody who was trying to enter a card, but it was wasn't recognizing the zip code or something. So you need to contact them because I don't have any control over that. So what do you guys think of the class so far? Hard, easy? You're gonna ace this, you're gonna own it? I'm scared.
I find it pretty hard.
So what is making it hard? Is it, and be honest, it's okay, you know, it's okay to be honest, and you got to be critical of yourself too. Is it finding the time to get everything squeezed in? Is it, I haven't really looked at the lecture, so I don't know. The book kind of sucks and it puts me to sleep. Yeah.
Kind of the lessons.
Kind of the lessons, the lectures. So can I ask you, did you look over the notes before you come to a lecture, or do you wait till we come to lecture and look at it?
I wait.
So can I give you a recommendation and it may help? So do you already have the book? Did you guys get the PDF of the book and download that one at least already?
I haven't, because every time I go to the bookstore and look for it, they sell out or they don't have it available.
Okay, yeah, because I know I have like 80 something students. So what you want to do is you want to download that PDF to at least get started, right? So if you look again under modules, again. And I know all of us instructors, we say exactly the same thing, you know, read the book, read the book, read the book. But let me tell you, it helps to at least look at it, you know, look at the pictures, look at the examples, because then that helps us a little bit, you know, to kind of get us in that right mindset. How many of you guys are visual learners? You like pictures, or how many of you guys can just read a book and then it just all seeps in and you get it perfectly?
I'm a visual learner.
I'm a visual learner as well. Okay, so if you look under Chem 22, getting started, that very first tab, that's your textbook, right? It's a PDF of that textbook, right? It's an old edition. It is also not very stable, right? And so that's the reason why I say get a good copy yourself, right? You can get an e-copy from them, that'll be a whole lot stabler. And but it's just to hold you off until you're able to get your book yourself, okay? So you click on that, it has all of the first few chapters. I think it has pretty much all the chapters, but again, when you get deeper into the book, it'll start crashing on you, okay? You guys understand that? So
Yeah.
what you want to do is before we start talking about the chapter, I'm going to let you know your reading assignments. I'm going to let you know. So chapter 2 was your very first reading assignment. The next reading assignment is chapter 3. I need to put that up there. So we're going to be doing chapter 3. We're going to start it today. We're going to finish it on next Tuesday. So we started today, we finish it on Tuesday. So your next chapter is going to be already put up there for you. Okay. So what I'd like you guys to do is look over the chapters, at least go through the book, open the book, and look at it a little bit before you guys come into the lecture. It makes it easier for you and also makes it easier for me, because then you have really plenty of questions rather than, I don't get it, and I don't get it questions, they're fine. I can deal with that. I can deal with not getting it, but it helps if you've kind of exposed yourself to it before. And you guys are in college, a lot of the classes that you're going to be taking is going to be done independently. You're not going to have somebody to hold your hand through it. And the lectures aren't going to be easy if you've not looked at the material or if you've missed the material. So if you missed that very first lecture, chapter 2, and me talking about the syllabus, then you need to go back and look at that as well too. So it's all about, the way to successfully pass this course, it's about give and take. You're going to have to give a little bit as much as you guys are taking. I can't give you everything. You guys are going to have to put some work into it on your own as well too. Okay? Does that make sense? Yes, no, maybe?
Yes.
Okay, good. Okay, so that's also being an active learner, right? So there's a difference between being a passive learner. Passive learner is what we do when we're in elementary school and when we're in high school. The teacher does everything for us, right? An active learner is the one that goes out and get it themselves. To be successful in life, you have to be an active learner. You guys get that, right? Because the passive learner gets passed by, right? Usually, like, they don't survive. They get eaten alive in college typically. Okay. So, and you guys don't want to be eaten alive, especially by me, right? Is that correct?
Yeah.
Good. Good. Okay. So we want to be active learners. So let's also talk about that Chem 101. So if you guys, let me find the course. Okay, so if you guys find your course, your next homework assignment is going to be chemical equations. You're actually going to be balancing chemical equations. I'm going to be adding that one up right now. So I'm going to publish it as we speak. So this will help you with balancing your chemical equations. Actually, let me fix that. Tuesday. We do not this Tuesday, but next Tuesday. Sorry. And I told you your homeworks were due on Monday. I'm actually going to give you guys till Tuesday because, we go over stuff in the morning. So by the end of the night, you should be able to kind of finish up on it. But we're like well ahead of our schedule here. Right? So we've already gone over balancing chemical equations. So this should not be something new for you. Okay. So you can see I already have your life already planned out. This guy is changed to there. There we go. First. Oh. So altogether, next week, you have 2 homework assignments that basically are going to be due. You're going to have 20 problems here and 20 problems here. I need to adjust your third one. This should actually be 4. Homework assignment number 4. And so I'm going to give you guys till Tuesday to do them. So 27th, actually 28th. Okay, and this guy. So any other questions? Anybody having trouble with the Chem 101 and how to use it since we're on Chem 101? Okay, good. I like it when there's no questions. That means I'm
I think
answering.
someone asked a question in the chat.
Oh, in the chat. Let me see. What did it say? Let's see. Do you know? Yes, they should be selling the code in the bookstore. Yeah, they should be selling the code in the bookstore. It's cheaper. It's cheaper if you buy it online. I think it's $33, $34 online. But if you buy it with the bookstore, it's going to be more expensive. So. And if there are any questions, or if you guys see something different, let me know, because again, I've not been to Hardnail's bookstore. I just send an email to somebody and they take care of things for me. And so there might be a delay. And so if there's a delay, let me know as well too. If you guys can't find the book, or if they're delaying it, and like you said, you have money stored up there because you won the Hardnail lottery and they put all your money into bookstore credit, then let me know, and we'll try to make sure that they take care of it. But they should have already had that taken care of. And plus, I think a lot of students sell their books back to the bookstore, so they should have at least a stock there. Okay. Any other questions? Good. And everybody's already started on the Chem 101 assignments?
Yeah.
You're like already on the third homework assignment,
Yeah.
Good. Okay, so let me pull up the lecture notes again. Got distracted. Okay. Okay, so we're going to start off with, so this chapter is basically, we're going to be talking about measurements, dimensional analysis, scientific notation. We're going to be talking about significant figures, conversions. So kind of the building block of what you guys should have learned in your math classes. If you didn't learn it, what you guys are going to have to do is you're going to have to pay attention to the lecture. You're also going to have to read our book and pay more attention to the lecture. And then also try to pull up your old math book and see if you guys did go over it and kind of refresh your memory on it. Okay. So there are going to be questions that you guys are going to see that deals with some of the things that you've done in the past. Okay, so let's start off with scientific notation. So this here is just a generic form of writing scientific notation. This here represents the number, right, that we're going to be working with. The form that we're going to want to write it in is, you guys can see that A dot B C D. So what I mean by that is you're going to have one number, decimal, and then you're going to have numbers following it. Then this is going to be times 10 to an exponent. So it's 10 to the third, right? So that's the same thing as this, 1,300. Okay. Now, how do I get from this to this? Well, if I had a decimal point following that 0, and I move that decimal point to make my decimal point. If I move it over 1, 2, 3, that's how we get that 10 to the third power, right? And so now I can put my decimal point there, and then I can use this factor of 10 to be written. Okay, does that make sense? So if I have a number like this, so if I wanted to write this guy in scientific notation, then my decimal point's here. I go over 1, 2, 3, 4, 5, 6. So then I would write this as 2.6. 7, 5, 9, 7 times 10 to the 6, 2, 3, 4, 5, 6, 10 to the 6. Do you guys see that?
Yes.
Okay. If the number is positive, that means that that number is a large number. If that number is negative for the exponent, that means that it's a very small number. So if I have 0.00001, 2, 3, then to write this guy in scientific notation means that I go in this direction. 1, 2, 3, 4, 5. Okay. Sorry. 1, 2, 3, 4, 5. So then I'll have 1.23 times 10 to the negative 5. Okay, since I'm going in this direction, it's going to be a negative. It's going to be a small number. We know that this 0.00000123, that's a really small number, right? Okay, so negative means it's going to be a decimal number, small decimal number. Okay, you guys get that? No? Yes? Maybe?
Yeah.
Okay, good. So I'm going to give you guys a couple of numbers, and then I want you to tell me what is going to be scientific notation for that. Okay, somebody want to help me out with this one? What am I going to do? Don't all you guys yell at me at once. Anybody there? Knock, knock. To the power, 6 power. Okay, so are you sure? So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. We want only one digit, then the decimal point. So it's going to be 2.954 times 10 to the 9th power. Okay, we want it in this format where we have a single digit, decimal point, and then the numbers that are needed to follow it. Okay, are you guys there? You guys get it? Okay, what about this guy? Okay, we have to the 10th. Let's see, that's 1, that's 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'll be 3.41 times 10 to the 10th power. And it should be a negative, right? Because it's going the opposite direction. Yeah, good job, Maria. Yes, that's right. Okay, questions, concerns, Cash? Now, I want to say something here. It's very, very important that you guys understand this. How many of you guys are really shy? I know Esmeralda's shy. She's just like, oh, I can't talk in front of anybody, right, Esmeralda? Kinda. Well, particularly with people that you don't know, right? You're like, when you know, you guys are like, no, you just won't shut up, right? Okay, so you guys this is your family, right? First off, you guys got to understand that. You guys are going to either make it together, right? So you guys got to get used to talking in front of each other. And that's either by typing or talking in front of each other. And the other thing is that you need to understand, it is okay to be wrong, right? I don't expect you guys to get it instantaneously. I expect you guys to make mistakes. Everybody makes mistakes. Now, if you're perfect, right, then that would be something different. But nobody's perfect, right? None of us are. I'm going to make mistakes all the time. If you talk to my girlfriend, she'll tell you that I make mistakes about 90% of the time, and I'm only right 10% of the time. Okay? So it's okay to be wrong, and it's better to be wrong right now in our class than you being wrong on the exam or in real life. Okay? So it's okay to be wrong. Get used to it. It's going to be okay. Get used to answering questions. Don't be scared to answer questions, because we learn better from making mistakes than we learn by getting things right all the time. You know? And so, like, I can tell you from my personal experience, if I got things right, if I never got in trouble, if I never made mistakes, I wouldn't have learned jack, right? I have to make mistakes. That's how I learn, because it pushes me to do better, right? And so I want you guys to do better. That means you guys have to be an active participant. That means that you've got to talk. Put yourself on the line, answer a question. It's not going to kill you. I promise. I'm not going to get upset and throw things at you. Even though I threatened to throw it at Paulina, but you know, that's because me and Paulina go back. Isn't that right, Paulina? We just met a few minutes ago. So, okay, are you guys with me? Thumbs up. Do you guys know how to give me reactions as well too? Because I need something. I feel so lonely. I'm gonna start crying here. So if you guys go under your menu table, it says more, or it'll say options. It'll say reactions. You can do a hand clapping. Do you guys see a hand clapping?
Yeah.
Or you can do thumbs up. Or you can do raise your hand. Okay, you guys see that? So if you guys can do that for me, it'll help me. It'll help me know that you're there. Okay. And again, don't be shy, because the only way that I know that you guys are having trouble or that you guys don't get it is if you talk, right? And if I seem short, let me know. Say, Dr. Henry, calm down. Take a chill pill, you know, go have a little bit of coffee, relax, you know, so, because it's never intended to be short. Okay. Are you guys with me?
Yes.
Good.
Yeah.
Okay. So let's move forward. Okay, so this is just basically, it's writing out step by step how you'd go about doing it. It's essentially the same thing that we just did. So you guys should feel pretty confident in doing this. Right? Okay, so here's some examples. Convert 3,672,199 to scientific notation. So what am I going to do? Walk me through the process. Which way am I going to move this decimal? To the left or to the right? This way?
To the left?
To the left. 1, 2, 3, 4, 5, 6. So then that would be 3.67219 times 10 to the 6th power. Okay. What about this one down here? So I'm going to move it to the right. 1, 2, 3, 4. Oops, I got carried away. 1, 2, 3. So it's 4.61 times 10 to the negative, since it's going to the right, -3, right? Good job. That's it. Not too hard. Okay. So okay, so if we're going from scientific notation to decimal, how would I convert this guy back to decimal form? So in this case, I'm going to take my point here, and then I'm going to move it over 11 spaces. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So then I just put zeros. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, so then my answer is going to be 0.0235, 6, 8, 9, 10, 3, 4, 9. Okay. And then this guy, what am I going to do here? Am I going to move the arrow to the, my decimal to the left or to the right? The exponent's a positive number. To the right. Okay, so that's 1, 2, 3, 4. So then my answer should be 5, 1, 6, 0, 0. Okay. So 51,600. Piece of cake?
Yeah.
How many of you guys already got your calculator? Okay. How many of you guys have your cell phone that has a calculator on? Okay, so at some point you're going to need to get a calculator. It's a good investment. You can get them at the dollar store for like, well, $3.99 or $2.99 or something like that. So real cheap, under $5. Now, the way that you would enter this number in your calculator is you type in 5.16, and then there's a button that says either EE or it'll say EXP. Okay, it'll be one of these two buttons. And then you type in that EE represents 10. It represents that times 10 to whatever power it is. So I'd type in EE4. Okay, and so that would give me this value. So if you guys can do that for me, is that what you got? Did you get this value? Okay, so if I wanted to type in this value down here, I would do exactly the same thing. The only thing I type in 3.49 EE. And then there's going to be a button that's either, it's going to be a button that says, it'll be parentheses, close parentheses with a minus sign in it, It'll be that button, or you'll see a button that says plus minus. Or you'll see a button that says plus minus in parentheses. So depending on your calculator. So what you're going to do is press that minus or that plus minus button. It'll put a minus up, and then you enter that number, 11. So, okay. So then that should give you this value. Okay. Do you guys see that? Did you guys see that button? One of these 3 buttons.
Yeah.
Okay. And so did it give you this value, 0.00000000349? Phone, the long way. So if you guys have an iPhone and you actually go to the calculator on your iPhone, you turn it this way, right? So it'll look like this. Okay. So then you enter that number, 3.49 EE. Here it's plus minus. Can you guys see it on my screen? Okay. So it's up here, and then 11. And so it'll actually show it to you that way, and then it'll show it to you scientific notation if I flip it this way. Okay. And so that E there represents 10 times, or it's times 10 to the 11th power. So that's what that E would represent. Okay. Not the natural log. Okay.
Luna, cállate.
Okay. So now
Sorry,
one more
that's my
time.
dog. He's barking at my landscapers.
Okay, it's okay. That's all right. I'm used to it. You should hear some of the things that happen at my house when I'm at home. Man. It's crazy. So when we're in chemistry, right, we're going to have what we call the quantity. Now, the quantity is always going to be the value and the unit, right? How many of you guys have been on Tinder? You guys, anybody know what Tinder is? Everybody knows what Tinder is, right? Okay, nobody's admitting anything here, right? Okay, so Tinder is a dating app, okay? So I went on Tinder, and then I put on Tinder that, you know how they ask you your weight, your age, and all that stuff, right? So I go on Tinder and I say, I weigh 100, right? Okay, so us being in the States, we're gonna think 100 means what?
Pounds.
Pounds. Now, if I weighed 100 pounds and you're a woman and I'm 5'8", and you think I weigh 100 pounds, what is the probability that you're going to date me? Be honest. Or if you're a man, you know, what is the probability that you're going to date me? Me weighing 100 pounds at 5'8" in height. Be honest. It's okay. I won't cry, I promise. At least not too much.
I mean, it probably wouldn't be like likely. I'd probably be more concerned if anything.
Yeah, you'd be like, damn, this guy is really skinny, right? He's 5'8", he weighs 100 pounds. There's something wrong. He might be an addict or something, right? He must be a meth head or something. That would be my instinct, right? If I was a woman or a man and I see somebody weighing 100 pounds, I'd be like, I don't know. So I would have a tendency, I would swipe. I can't remember which way you swipe, left or right. I would swipe to get rid of them, right? Because automatically, like, not gonna work for me, right? Okay, so that concept of units play an important part. If I told you that I weighed 100 kilograms, if you're a European, you kind of know the difference. So let me give you guys an idea. So 2.2 pounds equals 1 kilogram. So if I weigh 100 kilograms, how much do I weigh in pounds? Let me show you a way that you can figure that out. So I said I weigh 100 kilograms, kg, right? And I know that 1 kilogram is 2.2 pounds. Right? So my units are going to cancel out. This is called dimensional analysis. Then I could just multiply all the numbers that are up top. I multiply that across, and then I divide by the number on the bottom. So it'd be 100 times 2.2, which is 220. 220 pounds. Now you'd be like, okay, yeah, he's a little chunky, but he's cute. So yeah, he can stay around, right? So that would be good for me, right? So using units is going to be essential, because otherwise I don't know what you're talking about. 220, talking about pounds, or you're talking about kilograms, or you're talking about what, right? It makes a difference in what we're doing. If I told you, you guys, you have to be here in 5, is that 5 minutes? Is that 5 days? Is that in 5 years, right? You don't know unless I tell you, right? Is that true? 5 hours, right?
Yeah.
So we need to sit there and use units. We always have to include units to let us know what we're talking about, okay? So we need the value and the unit, okay? So in this example, express 50 minutes in seconds. So how many minutes will equal, how many seconds equal a minute?
60 seconds.
So 60 seconds equals 1 minute. Okay, so I have 50 minutes. That's considered my given. I know that this is a conversion that about seconds to minutes. So then I can use this conversion to figure out how many seconds I have. Minutes are going to cancel each other out. And I end up with 3,000 seconds. Okay, so now you guys will notice that I'm canceling these guys out, right? So this here, this line represents kind of like that division line. So if I have 2 over 2, what does 2 over 2 equal?
1.
1, because the 2's are going to cancel each other out, right? If I have x squared over x squared, what is that going to equal? X squared over x squared. Any number divided by itself should always equal what? What is 4 over 4? 4 divided by 4. Again, not all you guys yell at me at once. 1, okay? So 4 is just 2 squared over 2 squared. That's the same thing as saying x squared over x squared, right? Only thing now we're just putting a 2 there instead. So then x squared over x squared is going to be equal to what? 1. That's correct. That's it. So then if x squared over x squared equals 1, then what is minutes over minutes? cancel each other out. It's just 1. Okay, so we can use units and just the procedures that we use with math with our units as well too. Okay, does that make sense? So if I have minutes over minutes, and this is what that essentially says, then the minutes can cancel each other out. And then I'm just left with seconds. So then I know that my answer is going to be in seconds. Does that make sense?
Yeah.
Okay, let's. Okay, the oldest horse racing track in the United States is the 8-mile furlong Pleasantation Fairgrounds racetrack in California. What is the length of the racetrack in rods? Okay, so what is my given here? So this here represents as a conversion, right? So this tells me that I have 0.025 furlong is going to equal 1 rod. So I can write this conversion as either 0.025 furlong over 1 rod, or I can write it as 1 rod over 0.025 furlong. Okay, so I can write it in all these different ways, right? And it's going to mean exactly the same thing. It's just a conversion factor. So my given is what is given to me by the problem. So what is given to me in this case? The oldest horse racing track in the United States is the 8-mile furlong. So what's given to me? Anyone? How about that 8-mile furlong? That's going to be my given. So I'm going to start off with my given. I mean, 8 furlong. My answer, I want in rods, right? So I want to end up with my answer being in rods. So equal rod. Okay. So I want to get rid of furlong. So if furlong's on top, then I'm going to use this part of the equation. 1 rod on top, 0.025 furlongs on the bottom. Furlongs are going to cancel out. And then I'm going to be left with my answer, which I believe is. So that's going to be 320 rods. Okay. Questions? Concerns? Cash? Kool-Aid,